Let's start with a soap molecule, sodium stearate. You will recall that it's difficult to use soap, sodium stearate, with hard water. Instead, you get a scum. If you keep using the soap, the water will eventually soften as the soap reacts with all the calcium ions, forming a scum which floats to the surface as a solid. And once all the calcium has precipitated, the soap works normally and you'll start to get a lather again. However, this wastes soap, so we need to find something cheaper that will react with the calcium ions in the water and form a precipitate, sort of removing them from the water. Enter washing soda, sodium carbonate, much cheaper than soap. When you add the soda, the calcium ions join up with the carbonate ions, forming limestone as a precipitate, leaving water free of the hard ions. Now only the sodium ions remain in solution, balancing the sulfate or hydrogen carbonate that used to be with the calcium. You can remove temporary hardness by boiling the water, as we learnt in the previous unit, but this is expensive and causes lime to deposit on the sides of your container. So here's a question. What is the chemical change that happens when you boil water containing temporary hardness, that is, hardness caused by calcium hydrogen carbonate? Pause the video whilst you think of your answer. Well, the answer is that the calcium hydrogen carbonate splits up into calcium carbonate, which is the lime scale, carbon dioxide, and water. The best way to remove hardness is actually to use something called an ion exchange resin. These have a fixed anionic lattice, a bit like clay, initially balanced by positive sodium ions. As hard water flows through, the calcium ions are exchanged for the sodium ions, so that the calcium ions sort of stick to the clay and the sodium ions come out into the water. And in this way the water is softened because the calcium is no longer there. Obviously, after a time, the resin gets full of calcium ions and you have to reactivate it. And to do this, you pour concentrated salt solution, that's sodium chloride solution, very high concentration, so that it's high enough to reverse the reaction, and the calcium chloride comes out in solution, and the column is again full of sodium ions and ready for use. To compare the hardness of different water samples, you can take a fixed volume, say 25 cc's of the hard water, and run soap solution in from a burette bit by bit, shaking each time until the soap lathers. That means you'll see bubbles on the surface, and the more soap solution you have to use, the harder will be the water. To see how water is softened for public water supply, watch Environment 025 water treatment. So to summarize, to soften hard water, you need to remove the calcium ions which are in solution. This is done either by adding washing soda or by using an ion exchange column.